The topic is mixtures. Now, a substance that is made up of two or more than two substances that can be either elements or compounds mixed in any proportion and under any conditions. This type of substance is called a mixture. So, for example, gases present in air, they vary in their percentage from place to place or season wise. That is, carbon dioxide in air is more in industrial area. Water vapors are more during the rainy season. So, gases which are present in air, they vary from place to place or season wise. So, this shows that air is a mixture of gases. Now, components of mixtures they can be separated by simple physical methods such as filtration, sublimation, distillation, etc. Now, in the mixtures, the properties of its components they are retained. For example, iron is magnetic in nature, and if iron is present in the mixture of iron and sulfur, it shows still the magnetic properties. So this shows even if we form a mixture, the properties of its components will not lose because iron is magnetic in nature, and even if we take the mixture of iron and sulfur, it will still show its magnetic properties. Now, yellow color of sulfur is visible in the mixture of iron and sulfur. This also shows that the properties of components are retained when a mixture is formed, and sweet taste of sugar is retained in the mixture of milk and sugar. Now, mixtures can be of two types. They can be either homogeneous or heterogeneous. Homogeneous mixture is that type of mixture that has uniform composition throughout. The examples of such mixtures are mixture of alcohol and water. Milk is a mixture of fat content, water, proteins, etc. Aerated drinks, alloys. Alloys is also the mixture of various metals or non-metals. Now, heterogeneous mixture does not have the same composition throughout. That means that it does not have a uniform composition, so it has a non uniform composition. Examples of such mixtures are chocolates, chips, cookies, oil and water, and tomato noodle soup. So, these are the types of heterogeneous mixtures that do not have a uniform composition. Now let us read the classification of mixtures based on the physical state of the constituent. First is homogeneous mixture. The physical state of constituents is solid-solid. The example of such is alloy because alloy is a mixture of metals or non-metals which occur in solid state. Next is solid liquid. So the example of this is sugar solution because sugar is solid and it is dissolved in water which is liquid. Solid gas which is smoke. Liquid solid hygroscopic sodium hydroxide. Now hygroscopic is that type of substance that absorb water. Liquid mixture is alcohol and water. Liquid gas mixture is moisture in air. Now, gas solid mixture is whipped cream and foam. Gas liquid mixture is CO2 in cold drinks, which is CO2 is also present in aerated drinks. So, this is a type of gas liquid mixture. Gas mixture is air. Now, heterogeneous mixtures are those mixtures which do not have a uniform composition. The physical state of constituents is solid. The example is fruit salad, solid liquid, cereals and milk, solid gas, dust particles in air. Liquid solid can be water and semi frozen ice, jelly, and liquid, oil and water. Liquid gas can be raindrops in air. Gas solid can be gas adsorbed on the surface of charcoal. Gas liquid can be brown colored nitrogen dioxide that is known as NO2 in a closed bottle of nitric acid. So this represents a gas liquid mixture. And gas mixture is violet color iodine vapors in air. Now let us read about the differences between homogeneous and heterogeneous mixtures. Now the differences between homogeneous mixtures and heterogeneous mixtures is that first different constituents are mixed uniformly. That means it has a uniform composition. But in case of heterogeneous mixtures, the different constituents are not mixed uniformly, so they have a non-uniform composition. In homogeneous mixtures, the constituents cannot be easily separated, but in case of heterogeneous mixtures, the constituents can be easily separated as they do not have a uniform composition. I hope you understood this topic well. Thank you.